Example 4 says, consider the function f of x equals 2x squared minus 4x plus 1. We want to evaluate f of 3 and f of a. Let's start with f of 3. All this means is that everywhere we see an x, we want to replace it with 3. And now we want to use order of operations to simplify that expression. And so 3 squared is 9, so we have 2 times 9 minus, we know that 4 times 3 is 12, and plus 1. And then 2 times 9 is 18. And then 18 minus 12 is 6. And we want to add 1 to that, which gives us 7. So f of 3 is equal to 7. All that is another way of saying when I plug in an input of 3, my output is 7 for this particular function. Now, the second part of this asks us to evaluate f of a, and a is just a different variable here. Since a is not a number, we won't be able to simplify it, but let's see how we go about doing this. So f of a, just like we did in the previous one, anywhere we see an x, now we're going to replace it with a. So we have 2a squared minus 4 times a plus 1. And again, because a is a variable, we can't simplify this any further. So this is our final answer for this example. Example 5 says, consider the function g of x equals negative 1/3 x plus 2. Part A wants us to evaluate g of negative 6. So g of negative 6 is equal to, wherever there's an x, we want to replace it with negative 6. So if I were to simplify that, g of negative 6 is equal to, now these are both negative, so a negative times a negative is a positive. So if I wanted, I could rewrite this as 1/3 times 6 over 1 plus 2. And if we're following order of operations, we want to do the multiplication part first. So that is equal to, the way that we multiply fractions is we multiply the numerators together. So 1 times 6 is 6. And then we multiply the denominators together. 3 times 1 is 3. And then plus 2. And 6 divided by 3 is 2. So then we're going to add 2 plus 2 to give us 4. So our final answer is that g of negative 6 is equal to 4. Part B says, for what value or values of x does g of x equal 11? So basically what we want to do is we're trying to find the input values that would give us an output value of 11. And the way that we can solve this algebraically is we can set our equation equal to 11. So anywhere we saw a g of x, we're going to replace it with 11. And now we want to solve this equation for the x value. The first thing that I'm going to do is I'm going to subtract 2 on both sides. And if I do that, these 2's will add up to 0. And then on the left-hand side, 11 minus 2 is 9. So we get 9 equals negative 1/3 x. And then from here, I want to get the 3 out of the denominator, so I can multiply both sides by 3. If I do that, 3 times 9 is 27. And this 3 will divide out with this 3, so I would just be left with negative 1x or just negative x. Those are equivalent. And then to get rid of the negative sign, I would multiply both sides by negative 1. So if I move on up over here. Negative 1 times 27 is negative 27, and then negative x times negative 1 is positive x. So that is our answer there, and we can say g of negative 27 equals 11. Now, we could do a quick check. We could plug that in to see if that does in fact give us 11. So let's go ahead and do that. So if I plugged in negative 27, so g of negative 27 would be negative 1/3 times negative 27 plus 2. And if I simplify negative 1/3 times negative 27, the negatives would like cancel each other out. So it would be 27 divided by 3, which is 9. And then we would add 2 to that, which would equal 11. So that checks off. And we've gone ahead and we're able to check our answer that way. Part C says sketch a graph of g of x on the grid provided. So I'm going to label my axes. The vertical axis, you could call it y or g of x. And the horizontal axis, I will label with an x. Now, let me just rewrite the equation really quickly. So we have g of x equals negative 1/3 x plus 2. And so, there are multiple ways that you can go about graphing this, but I'm going to start off with the y-intercept, which is the point 0, 2, because it's always 0, b, whatever our b value is, and in this case our b value is 2. So I'm going to go ahead and plot my ordered pair 0, 2, and then we know that the slope is negative 1/3. So from that point, we could go down 1 unit and then right 3 units. So that would end us up at the ordered pair 3, 1. And then just for good measure, I'm going to do that again. So I'm going to go down 1 unit and then right 3 units. So that would give us a dot at 6, 0. Then I'm just going to use my ruler to create a line there. And then draw arrows to indicate that the line goes on forever in both directions. Part D says, what is the domain and the range of g of x? Now, unless otherwise stated, or maybe you're dealing with a word problem, in general, whenever you're dealing with a linear function, the domain and range are both going to be all real numbers. And hopefully you can see that from the graph. If I highlighted the x-axis, really you could plug in any x value into your linear function and you would get some sort of output value. And hopefully you can see that there's any number that you could possibly think of as an output value, there's going to be some input value that exists that will give you that specific output value. So that's just another way of saying that both the domain and range, specifically for linear functions, is always going to be all real numbers. And that's how you write this in interval notation. So again, linear functions will always have a domain and range of all real numbers unless otherwise specified, or you are maybe dealing with a word problem. In some cases, for example, it doesn't make sense to plug in a negative value into a linear function if it's dealing with some kind of word problem or something like that.